Hey everybody. So this video we're going to talk about continental drift, which is all to do with how the continents have moved over time on Earth. Because we know that the continents aren't just staying still, we know that they've moved in the past and they're still moving right now, and they'll be moving in the future as well. So what you need to learn in this video is you should be able to give an explanation of plate tectonics and continental drift, and then be able to describe how the continents generally have changed since Pangaea, which was a supercontinent. And we'll learn about that later. Okay, so first of all, we need to know what plate tectonics is. And this is a theory. So remember, in science, theories aren't like we use the word in everyday life. Theories are confirmed by hundreds and hundreds of different experiments. So they're essentially, as far as we know, 99% true at least. And there's hundreds of experiments that have proven plate tectonics to be true. So plate tectonics is the fact that all the continents on Earth are sitting on top of layers of rock that are called continental plates. Which you can see in the diagram here. And then all the continental plates, they're sitting on top of the layer of the Earth that's below the crust, which is called the mantle. And the mantle is made of really, really hot rocks. They're not liquid, like they're not made of lava, but they're so hot that over time they can bend and they can flow just like a liquid could. So they're hot rocks that can flow like a liquid or like a fluid. And a really good analogy is if you've got a pot boiling on the stove, and when you get all these layers of bubbles on the top of the pot, that's the bubbles are modeling the continental plates. And so they sit on top, and because of the heat bubbling up from below, that tends to move the bubbles around and they break apart, they swirl around, they join together again, and that's how the continents move. And that process of the heat coming up from underneath and pushing the things on top, that's called convection. And so the mantle has convection, which pushes the continental plates and they move around. So here's a map of all the continental plates on Earth. And scientists have mapped them. We can use satellites and we can use sonar to map the ocean floor, and we've figured out these are all the different plates. So here we are on the Australian plate here. And we can actually measure where our plate is moving. And at the moment, we're heading pretty much to the north. And we can measure it using satellites, and we've actually figured out we're moving about 6 centimeters north every year. So that means each year we are 6 centimeters further to the north, closer to the equator, than we were the year before. And if you think about adding up millions and millions of years, that 6 centimeters can add up to really long distances. And that's how the continents change over time. A few centimeters each year, but it's such a long time that they can move really far. And that is basically continental drift. So it's the fact that continents move over time, which is caused by plate tectonics that we just learnt about. Okay, and here's some maps of the Earth at different stages. So here's one 500 million years ago. We've got a supercontinent at the bottom in the south here, which is Gondwana. And we've got a few other small continents. about 250 million years ago, all the continents had joined together into Pangaea, which we'll talk about in a second. And then over the last 200 million years, all those continents have separated again to give us what we know as our modern world today. But things will change, like Australia's moving north. The Atlantic Ocean's going to close again. So Africa will join up with the Americas, and there'll be lots of different things changing if you were around in another 100 million years or so. Okay, so that leads us on to the supercontinents, and we need to be able to know the 3 supercontinents that are the most recent ones, and how big they were and what happened to them over time. So essentially, a supercontinent is just a continent containing lots and lots of continents from today. So they contain multiple present-day continents. And these are the 3 most recent ones. So we've got Pangaea, we've got Gondwana, and we've got Laurasia. And as we'll see in the video in a second, they each contain different continents. Pangaea, it contained every single continent. So it's the biggest supercontinent that's ever existed. Gondwana is the southern continents, and we'll have a look at which ones in particular. And Laurasia is the northern continents. So obviously Australia, we were part of Gondwana millions of years ago, and that's affected the species that we have in Australia today, because only the species that evolved in Gondwana generally were able to exist in Australia and evolve into what we've got today. So Gondwana are the southern continents and Laurasia are the northern ones. Okay, so we're going to have a look at a video now showing how Pangaea, the supercontinent, broke up into the other 2. And we generally need to be able to explain how it broke up and which direction the main continents moved in until we get to today. So firstly, we're starting Pangaea at around 300 million years ago. MYA is million years ago. And let's have a look at what happens. So here we go, every continent. We're still one big continent in Pangaea. By the time we get to 200 million years ago, we've started to split off in the north, and there we go. By about 150 million years ago, the northern continents broke off into Laurasia, and the southern continents broke off into Gondwana. So let's just go back there. So when we reach 150, the northern parts of Pangaea became Laurasia, and then the southern continents became Gondwana, and there we go, Gondwana starts to split off, and South America, Africa, and Australia all split off from Antarctica, which stays in the south. Okay, so we need to be able to show and explain what happened there. So around 150 million years ago is when Gondwana broke off to the south and Laurasia broke off to the north. Alright, so that's the basics of continental drift and plate tectonics and the general story of where the continents have gone in the last 300 million years or so.